Hi, my name is Holger Hornes. I'm the manager of Intelligent Systems at Pepperl+Fuchs. In this video, we will cover another configuration example for our safety controller. In this example, we're going to go through the setup of a solenoid, a door locking solenoid. This is a key operated switch where the key can be captured, and the safety device that I have here is a so-called power to unlock device. That means if there's no power supplied to the solenoid, then I will not be able to pull out the key, therefore open the door. I also have an e-stop that is used to override everything as a general machine shutdown. A couple of things I want to go through. First is here is the definition or the logic that is utilized for controlling motor 1, the safe output 1, that then connects to the safety contactor. So what I have here is the solenoid interlocking switch is run into my global AND, and I have an e-stop. And for a reason that's not immediately evident, I will utilize what is called a button device, and I use this button device in conjunction with the input contact S72 on the safety controller. So what this allows me to do is, if I double click on the e-stop, this allows me to run the e-stop in and by itself as an automatic start function. Later on it'll become a little clearer why I need to do that. I do not have the local acknowledgement selected here. So therefore, by utilizing this button, I reset the e-stop using S72 through the button input. Okay? So when we download this to the controller and run it, it becomes a little clearer why I have everything set up the way I have it. And then we will also look into this sheet that you see here in the background. It is the logical definition for the second safe output that's available on the controller. And then up here, this is a third sheet, and this is a, I don't want to call it a trick, but there's a way to utilize higher OSSDs that are not really available to the controller. There is no such thing as an OSSD 9, but I can use it to put together other logic functions that I can then use. So again, running this should make it a little clearer. Let's take a quick look at the hardware setup, and in particular the I/O configuration. For this example, I have only two safe devices. Both of those are dry contacts, so that's why the radio buttons are over here. And for this example, I have utilized the contact set S5, S6 also as standard input and messaging input. And the reason I have that done is just to show it that it's possible, and secondly, I have connected an input, or I use input S61 as my signal to unlock the door. So when that signal is connected to 24 volts by virtue of a button or perhaps from a PLC, whatever you select to do, then the door switch will be unlocked because power is applied to the solenoid, and now the key can be removed, which is equivalent to opening the door. Okay, that's really the only change here. So let's go and download this to the monitor as before. Okay, now we're in diagnostics mode, and what we can see is that the solenoid interlocking switch is giving us a green, a true signal. That's because the key is inserted and the switch is latched. Also, the e-stop is released, but the button function does only provide us with the yellow ready signal. That's simply because I have not activated the S72 input. So as soon as I do that, everything starts up. So let's just check this out real quick. I push the e-stop, the system goes to shutdown. I release the e-stop, I can restart. Because the interlock is latched, I'm not able to pull out the key. So what I need to do in order to open the door, I need to provide 24 volts and a fair amount of current to the solenoids that are inside of that switch. Recall please that the signaling, the messaging outputs are not going to be strong enough to provide the necessary current. So those are per data sheet 10 milliamps of current. They're good for LEDs, they're good for inputs into PLCs, this kind of thing. But they're not going to be strong enough to unlatch, to pull in the solenoid on this door switch. So therefore, I am utilizing OSSD2 as my means of turning on the solenoid. So I use the safe output 2 that's on the controller to do that. And so the logic that I have looks a little complicated, but it really isn't all that bad. So you can see what's important is that the unlatch right now is red. That means there is no current flowing to the solenoid. In order to do that, I need to turn on this flip-flop. And we've talked about flip-flops earlier. Flip-flops have a hold condition and a set condition. The hold condition is latched in by the flip-flop when the set occurs. And in order for the set to occur, you can see down here, that is my input S61. So all I need to do is I need to turn that signal true, and again, I could do that from a PLC or by virtue of a button that I locate next to the door. When I provide 24 volts to this input, then the set will be true, and because the hold is already true, everything here, the flip-flop, will turn true, which will power OSSD to the output and therefore unlatch the door. So let me do that. I activate, and now I can open the door. You already heard that in the background the safety contactor dropped out. The reason that is that the mechanical construction of this particular door lock switch that I'm using here is such that when the coils are pulled in, then the switch will provide a false signal. And false is, again, on this screen, it's here. The interlock switch will in fact turn off. So as soon as that is turning off, then of course my motor contactor will drop out. The logic that you see here has the property of being self-resetting. That means that after a defined amount of time, and the amount of time is done in this off delay, and I selected 5 seconds here. After 5 seconds, the door would either relock in case the key is inserted, or if I now insert the key, it will immediately restart. So let's do this again. I activate my unlatch input. That will shut the machine down. I could open the door, but if I don't do that, then after 5 seconds it automatically latches again. And since I have an auto start here, it will do that automatically. Of course, as you know, I could put some sort of a reset in here if that's more suitable in this particular case. Okay, so that is that function. There's another sheet here in the background that I would like to discuss, and this is associated with OSSD9. There is no such thing as a physical output number 9 on this device. And what I use this for is to provide feedback to the PLC that signals when the e-stop is in the ready to be reset state. So what I can do is I can push down on my e-stop, and as a result the e-stop here will turn true, and this entire logic chain, as you can see, the e-stop will turn red and the entire logic chain turns red. So OSSD9, which I need to stress this again, is an internal number, is not tied into any physical output, is therefore in the false state. But When I pull out this e-stop, then the e-stop is in the resettable state, and this logic chain turns green. So OSSD 9 signals to me when the e-stop can be reset versus when it's not in a resettable state. And that function can then be utilized on the assignment screen, and I need to find it by scrolling down here. Okay, so here we go. Oh, that was a little too far. I assigned one of the available outputs, signaling outputs, to state of switching element 2. No, sorry, that is state of switching element 2 is the fact that the door is unlatched. It's here. It's S71, output, signaling output S71 is assigned to the internal variable state of output switching element 9. State of output switching element 9 is internally used to signal that I am in a resettable state. So now my output S71, my output pin S71, clearly shows me if the e-stop is resettable or not. So here I provided a fairly simple means of signaling to the PLC that my e-stop can be reset. Now I want to point out something very important. When you install Simon Plus, you will not get this function block. This is a not function. The reason that was omitted is it is a function, if not utilized properly, can result in unsafe safety configuration. So as a precaution, we left it out. Nevertheless, we provided a method by which you can activate it. It's something you have to do, and we give you the instructions for that. But we also warn you again on the instruction sheet that you need to be very careful with the not function, or you will end up with unsafe situations. Generally speaking, if you use the not function in something that is diagnostics related, like this particular set of logic, this does not control any output, this does not control a motor, it simply is utilized to give me a diagnostics output, a signaling output to the PLC, then of course there is no harm. But if you use it in any logic that has anything to do with a safe output, you need to be extremely careful, and the best advice is probably to not use the not function at all. On the other hand, I also have to say that if you do not have the not function activated, then this operation, signaling the ready state of an e-stop, cannot be accomplished. So this is something you need to decide if you want to turn it on or not, but please be careful with the not. This concludes this example. I hope you found this configuration example helpful. Please watch our other videos discussing the Pepperl+Fuchs safety controller.